All right, so this is going to cover Module 9, Homework 2, which is equations of lines. So in this section, we're going to find the slope. We're going to use the slope to determine how our line is slanted. We're going to write the equation of the lines. We're going to use slope-intercept form to find the slope and the y-intercept. We're going to write the equation of horizontal and vertical lines. We're going to graph the equations. We're going to write the equations using function notation. We're going to see if they're parallel, perpendicular, or neither. And we're going to write the equation of parallel and perpendicular lines. So starting off, so all more of the same, kind of just adding to it. So starting off, slope-intercept form is what we talked about last section, which is y equals mx plus b. Where m is the slope and b is the y-intercept.
The little note at the bottom says in standard from. Is it supposed to say form?
Oh, you're right. You're right. That's funny. No one's ever caught that. Thank you.
You're welcome.
In standard form. All right, so that's our slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So standard form, which we talked about a little bit last section, even though we didn't really introduce it yet, I guess. But now we're introducing it formally. So standard form is ax plus by equals c. So notice our variables are on one side and it equals to some number. A, B, and C are just numbers. Note they are not fractions, so they cannot be fractions. So our variable's on one side and it equals some number. So we're going to use slope-intercept form of the linear equation to write the equation of the line with the given slope and the y-intercept. So kind of working backwards. Last section they gave us the equation. We had to find the slope and the y-intercept. This time they give us the slope and the y-intercept and we need to write the equation. So our slope, which we know is m, is going to be -9. And our y-intercept, which we know is 0, b, is 0, 5. So we know our b value is 5, our m value is -9. So plugging those values into our slope-intercept form of y equals mx plus b, we get y equals -9x plus 5. Done. I just plugged in m is -9, b is +5. I want to leave x and y as x and y because that shows me that line goes on forever, which we talked about in either direction. So it could be any x and y, any point, so I want to leave it as x and y. So next example, write the equation of the line having the given slope containing the given point. And we're going to write our answer in slope-intercept form. So this time they give us the slope. So they tell us our m value is 4. But this time they don't give us b. It just says it's through 4, 1. 4, 1, just one random point. So it's just a random x value and y value. So I don't know b. I need to find b. So let's plug what we know into our slope-intercept form, which is y equals mx plus b. They gave us a y value of +1. They told us our slope, our m value is 4. Our x value that they gave us is +4. And I don't know b, so plus b. So we need to use what they have to find b. So simplifying this, 1 equals 4 times 4 is 16, plus b. Getting b by itself, I can subtract 16 from both sides. So 1 minus 16 is -15, equals b. So I now know my slope and I now know my y-intercept. So now we can plug it into our slope-intercept form, which is y equals mx plus b. We know m is 4. We know b is -15. So plugging those values in, we get y equals 4x minus 15. Or you can do your plus to -15, which is still good. questions, comments, concerns so far? So taking what we did last Module 9 Homework 1 and just kind of adding to it. We're going to keep going with it. If no questions, let's keep going. So now it asks us to write the equation of the line passing through the given points using function notation. We've seen function notation a little bit ago, and that was with f of x. So function notation just says to use f of x instead of y. So f of x instead of y, because they want to be fancy. So this time, they just give us 2 points. They don't give us the slope, and they don't give us the y-intercept. So we have to find it all. But we can do that. They give us 2 points of -1, 5 and -4, 14. So I'm going to label this first point as x1, y1. I'm going to label the second point as x2, y2. And we can now find the slope by plugging into our slope formula, which is y2 minus y1 all over x2 minus x1. So we said y2 was 14 minus y1 was positive 5 all over x2, which is -4, minus x1, which is -1. So up top I have 14 minus 5. On the bottom I have -4. Those two negatives will become a positive, so -4 plus 1. So up top, 14 minus 5 will give us 9. All over -4 plus 1 will give us -3. 9 divided by -3 is -3. So we found our slope. So we know that our slope is -3, but we still don't know b. But we now know our slope, and we can use either one of those 2 points, like we did on the previous problem, plug it all in, and use that to find b. So plugging into our slope-intercept form, plugging into y equals mx plus b, we're going to plug in m and either one of those 2 points that you like better, and either point to solve for b. So plugging in our m and either one of the 2 points. I'm going to use the first point because -1, 5 looks just a little bit easier. I kind of like this one better. Totally up to you. So our y value is 5. Our m value is 3. Our x value is -1. And we don't know b, so we're going to leave it as plus b. But now I can use this to solve for b. The door was locked. All right, so now we can solve for b. So 5 equals 3 times -1, which is -3, plus b. Module 9, homework 2. So adding, yeah, did I mess up?
No, maybe it's me, but so it equals -3, but m is 3. Like it equals 3. Why isn't that -3?
You're right. You got me. I was making sure you're paying attention. You passed. Good job.
I just didn't know.
No, I just messed up. My bad. So m is -3. So now -3 times +1 is +3. Thank you for stopping me before I got too far. So -3 times -1 is +3. Here we go. Thank you again. So 5 plus, no, now I'm like totally frazzled. So 5 equals 3 plus b. Solving for b, I can subtract 3 from both sides. And we get 2 equals b. 2 equals b. So we got everything we needed. We got our m value, we got our b value. So plugging this in to y equals mx plus b. Y equals our m value is negative 3x. Our b value is positive 2. So boom, our final answer is not this. Close. Y equals negative 3x plus 2. What are we forgetting? What's the last step? Function notation. Good. Instead of y, I need f of x. So instead of y, I'm going to write f of x equals negative 3x plus 2. Now this is our final answer. For real this time. So we did one together. The next one is the exact same thing. Let's do it together. Or you want to do it by yourself, go for it. If you don't, I'm going to do it up here. So I'll try to talk quiet if you're doing it by yourself. But they gave us 2 points and it asked us to find the equation of the line passing through the given points. And again, we're going to use function notation. So function notation again just means we're going to write f of x instead of y. So giving us 2 points, we need to find our slope and we need to find our b value. So I'm going to label the first point as x1, y1. Our second point as x2, y2. Our first point is negative 3, negative 7. Our second point is negative 6, negative 8. So plugging that point, those 2 points into our slope formula, which is y2 minus y1, all over x2 minus x1. y2 is negative 8 minus negative 7, all over negative 6 minus negative 3. The 2 negatives will become positive, so it's really negative 8 plus 7, all over negative 6 plus 3. Negative 8 plus 7 will give us negative 1. All over negative 6 plus 3 will give us negative 3. Negative 3 divided by negative 1. The 2 negatives will cancel each other out, and we're left with our slope is positive 1/3. Our m value is positive 1/3. The reason why I put this one in there is it's just a little bit trickier because it's fractions and no one likes fractions and everyone gets scared. So I'm just going over one with fractions. So plugging this stuff in, just like we did before, to our y equals mx plus b slope-intercept form. All I have are the points and my slope. I don't know b yet, so I need to use this information I have to find b. I'm going to plug in, doesn't matter either point. I'm going to pick the first point to plug in, negative 3, negative 7, and our slope of 1/3. So we have negative 7 equals 1/3 times negative 3 plus b. Negative 3 is like negative 3 over 1. So when I multiply fractions, I multiply straight across. So negative 7 equals 1 times negative 3 is negative 3. All over 3 times 1 is 3. Plus b. Simplifying this down, negative 7 equals negative 3 divided by positive 3 is negative 1. Plus b. So I have negative 7 equals negative 1 plus b. Getting b by itself, we can add 1 to both sides. And we will get negative 6 equals b. So for y equals mx plus b, we want to use function notation. So instead of y, we're going to write f of x. Our m value is 1/3 x. Our b value is negative 6. So our final answer is f of x equals 1/3 x minus 6. So looking to see at what you did, if you did it by yourself. If not, looking to see what we did together. What questions, comments, or concerns do you have for me before we move on to the next example. Next example. Instead of giving us information like 2 points, it gave us the graph. And it asked us to find the equation of the line graphed, and we're going to write our answer in standard form. Remember, standard form is ax plus by equals c with no fractions. So looking at this, I need to find the slope and the y-intercept first, because the only equation I know how to write is slope-intercept form. So they give us kind of 2 points right here, which is -3, 2. And this point is over 5 up 8, so 5, 8. So I can use those 2 points. Now it's exactly like the other problems we did. We can find the slope. We can find the y-intercept. So, only thing is another option we have is we can count to find the slope and the y-intercept. Our slope going from one point to the next. We read from left to right, so we're going to go from the left point to the right point. I'm going to go up 1, 2, 3, 4, 5, 6. So my slope is rise over run. I rose, I went up +6. And I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go right 8. So I'm going to go over 8 in the positive direction. So if you plug in y2 minus y1 all over x2 minus x1, you'll still get 6 over 8. Or if you count it, either way, we're still seeing your rising and you're still seeing your running. So 6 over 8, how could I simplify 6 over 8? What GCF could I factor out?
By 2.
By 2.
And 3 over 4.
Perfect, which will give us 3 over 4. Thank you. So we know our slope is 3 over 4. We still don't know our y-intercept. I can look to see it's like 4 point something, but I can't put 4 point something and have it be right. So I'm going to use one of these points and I'm going to use the slope to find the y-intercept. So y equals mx plus b. We can use, let's use the first point. So +2 equals 3 over 4. Our x value is -3 plus b. If it helps you to write it as -3 over 1. So multiplying across, we have 2 equals +3 times -3 is -9 over 4 plus b. Last but not least, getting b by itself. I can add 9 over 4 to both sides. So I'm left with 2 plus 9 over 4. As they are not common denominators, so they are not like terms, so I cannot add it as it is. But if I get common denominator, so 2 over 1, my LCD should be 4, so I'll multiply the top and the bottom by 4. So that'll leave me with 8 over 4. So now I have 8 fourths plus 9 fourths, which will give me 17 fourths equals my b. Now that's the part that everyone hates. So if that really trips you up, I'm going to show you how to do it in your calculator. So in your calculator, if you do 2 plus, in parentheses, 9 over 4, the reason why I want to do it in parentheses is to separate that 9 fourths as its own fraction, equals 4.25. I want to change this decimal into an improper fraction. Our first thing we have to do is, do you see above PRB it says F to D? So that goes from fraction to decimal. So second, it's in light blue, so I need to hit the second button. PRB, so turning our answer from a fraction to a decimal, pressing enter. That will give us 4 1/4. That's a mixed number. I don't want that, so we need to do one more step. Right below it is this ABC button, and it turns our mixed numbers into improper fractions, which is what we want. So second, hitting this ABC button, boom, that'll give us our 17/4 that we're looking for. Questions, comments, concerns for me. So everything could be done in your calculator that you'll have for the test.
They can't be fractions
What do you mean?
for the answers?
No, it has to be a fraction. Oh, for our final answer, yes. Keep that in mind. Pause that thought for 1 second. All right, so putting everything back together. So y equals mx plus b. We now found our slope was 3/4. X plus our b we found was 17/4. Remember, we want to leave x and y as it is. So you're right, we cannot have fractions. So what did we do in Module 7 to get rid of these fractions? Fractions mean divide, so what's the opposite of dividing? Multiplied by what?
4.
4, the LCD, perfect. So we're going to multiply everything by 4, which is 4/1, by our LCD to get rid of our fractions. So let's distribute that positive 4/1, just like we did on Module 7. So do you see how it's all coming back into play? So 4 times y is 4y equals 4 times 3 is 12. All over 1 times 4 is 4. X plus 4 times 17. 68, thank you. All over 1 times 4, which is 4. And then when we simplify the fractions, they should go away now. So 4y equals 12 divided by 4 is 3. So 3x plus 68 divided by 4 will give us that 17. So we got rid of the fractions. That's what we wanted for standard form. Last but not least, we want it in the form ax plus by equals c. So I need to move this 3x over here with the 4y. We're going to subtract 3x from both sides. So our final answer will be negative 3x plus 4y equals 17. Final answer. All right, so it asks us to write the equation of the line in standard form. Remember, standard form is I hear ya. Ax plus by equals c. Remember, with no fractions. So in other words, we have our x and our y, we have our variables on the left-hand side, and it equals some number. So it asks us, this line is vertical, so up and down, through the point -1, -5. So if we have a vertical line, that equation is going to be x equals. So the way that I think about it is our x-axis is horizontal, so x equals is the opposite, it's vertical. Y-axis is vertical, y equals is the opposite, it's horizontal. So in this case, our x equals -1. So x equals -1. Boom, we're done. We are done. That's in standard form because I have no fractions. I have my variables on the one side and the numbers on the other. That's it. That's it. Same thing for the next one. Write the equation in standard form. This time it's horizontal. So instead of x equals, what will it be? Y equals. Good. So this one, in this case, y equals -3. No fractions. My variables are on one side and it equals some number, so it's in standard form. Boom, we're good to go. Before we move on to the next example, what questions, comments, or concerns do you have for me, please? If not, let's keep rolling. Find the equation of the line through the point 1, 6, and is parallel to y equals 4x minus 8. We're going to write using function notation. So remember function notation, we're going to use f of x instead of y. Sorry, wrong problem. I was writing, but it was running down here. F of x instead of y. What do we know about parallel lines?
They don't touch.
They don't touch. What else?
Either horizontal or vertical.
They're horizontal or vertical. What else? I need a gain. We have a point and we need a slope.
They're
Same slope.
Same slope. Same slope. If they don't ever touch, if they run parallel to each other, that means they have the same slant. That means they have the same slope. Looking at y equals 4x minus 8, what is this slope? Okay. Y equals mx plus b. So it's in slope intercept form.
Y equals 4.
Good, or close.
4 over 1.
So our slope, which is our m value, equals 4. It's just a number, so no x, just 4. So now I have an m value, the same slope, so I know m is 4. And they give me a point, so they give me an x and a y. They give me 1 and they give me 6. X is 1, y is 6. I can plug what I know into my equation and use that to solve for b. So my equation is y equals mx plus b. We said y is 6, m is 4, x is 1. I don't know b, so I'm just going to leave it as b. But now we can use this equation to figure out b. We can solve for b. So we have 6 equals 4 plus b. Help me out. How could I get b by itself?
Minus 4.
Perfect. Subtract 4 from both sides. So that way 6 minus 4 will give us 2. So that way I know that our b value is 2. So I know our slope is 4 and our b value is 2. So putting this back together in our final answer, y equals mx plus b.
F of x.
We're going to use f of x instead of y. Perfect, because it's function notation. So f of x equals, m we said was 4. I want to leave x as x plus b, which we said was 2. I want to leave f of x and x. I want to leave those variables there, represent every single point on that line. So our final answer is f of x equals 4x plus 2. 4x plus 2. Questions, comments, concerns for me so far? If not, let's do another example. Same concept. Now we have to find an equation of a line through the point 3, negative 8. So they give us x is 3, y is negative 8. Perpendicular to 9x equals, 9y equals x minus 18. And again, we're going to write using function notation. So we're going to use f of x instead of y. Before it was parallel slopes. Now they're perpendicular lines. So what do we know about the slopes of perpendicular lines? Opposite reciprocals. Good. Opposite means one's positive, one's negative. Reciprocal, which means we're going to flip the fraction. Slopes. So opposite reciprocal slopes. So looking at 9x equals x minus 18, is this in slope-intercept form? So that way I can see my slope. Not yet, but it's close, right? So if we have 9y equals x minus 18, I want to try to get y by itself to put it into slope-intercept form so that way we can see the m value, the slope. How can I do that?
Divide by 9.
Divide by 9. I'm dividing the left side by 9. That means the right whole side gets divided by 9. So I have y equals x over 9 minus 18 over 9. Right. So I have 1/9 x minus 18 divided by 9 is 2. So now this is in slope-intercept form of y equals mx plus b. So what is this slope?
1/9.
1/9. But I don't want, I want this slope, but I cannot use this slope. I need to use the perpendicular slope. So what's our perpendicular slope going to be?
9.
Yeah, 9 over 1. And what else?
Negative.
Negative. Good. Sorry, you might have said that. I just didn't hear you. Perpendicular slope. This one's positive. Our perpendicular one's going to be negative. And we're going to flip it. Instead of 1 over 9, it's going to be 9 over 1. So our new slope that we're going to use is going to be negative 9. So over here, our slope that we're going to use is going to be negative 9. And the point we're going to use is going to be 3, negative 8. So x is 3, y is negative 8. So we just found this slope so that we can find the perpendicular slope. Now that I know the perpendicular slope is negative 9, that's all I need. Because we're trying to write the equation that's perpendicular. So now that I know a slope and a point, I can plug this into my y equals mx plus b formula. Our y value is negative 8, m is negative 9, x is 3. I don't know b, so we're going to leave it as plus b. I can now use this equation to find b. So we're going to solve for b. So we get negative 8 equals negative 9 times positive 3 is negative 27 plus b.
Add 27.
Add 27 to both sides. Thank you. Read my mind.
Positive 19.
And we'll get negative 8 plus 27 is positive 19 equals b. So now we can write our final answer. So we know y equals mx plus b. We want to use function notation, so instead of y, we're going to use f of x. We know the perpendicular slope that we're going to use is negative 9. I want to leave x as it is, plus b, so we have plus 19. And that's our final answer. F of x equals negative 9x plus 19. Questions, comments, concerns for me, please. If not, you're ready for the next page. So next page, 2 more examples for this section. Find the equation of the line in standard form. Again, remember standard form is ax plus by equals c with no fractions. With no fractions. They give us 2 points. Let's go ahead and let's find the regular equation in slope-intercept form, and then we'll worry about changing it into standard form later. So just like a normal problem we would do, first we need to find the slope. Our 2 points are negative 2, negative 8, and 0, negative 9. So I can label this first point as x1, y1, and the second point is x2, y2. So that way we can find the slope by plugging it into our slope formula, which is m equals y2 minus y1 all over x2 minus x1. Plugging in the values they give us, we have negative 9 minus negative 8 all over 0 minus negative 2. Plugging in our values that we labeled. Two negatives become positive. So we really have negative 9 plus 8 all over 0 plus 2. Good. So negative 9 plus 8 is negative 1. All over 0 plus 2 is 2. We get negative 1/2 for our slope. We get negative 1/2 for our slope. So we found m, but we still need to find b. Just like on the previous problems that we did, we can take our slope, which we just found was negative 1/2, and either point, what point? The 0, negative 9 looks a little easier, but it doesn't matter, either point. So that way x is 0, y is negative 9. I can plug this information into my y equals mx plus b formula to solve for b. So you have negative 9 equals negative 1/2 times 0 plus b. Negative 9 equals negative 1/2 times 0 is 0. 0 plus b is still b. So we know negative 9 is our b value. We're getting closer. We're getting closer. Putting this all together. Y equals mx plus b. We know m is negative 1/2. X, and we know our b value is negative 9. So y equals negative 1/2 x minus 9. So that's our equation. But this equation's not in standard form. This is in slope-intercept form. So we just take this equation and just play with it to get it into standard form.
Add 1/2 x.
First thing is there's no fractions. So I need to get rid of the fractions. How could I do that? How have we been doing that with module 7 and stuff? Close? Yeah, I mean, you're right, but what?
Multiply by reciprocal.
Multiply by reciprocal. So let's multiply by the LCD. Fractions mean divide. So in order to get rid of the division, in order to get rid of the fractions, we need to do the opposite. We need to multiply. So what's our LCD for y equals negative 1/2 x minus 9? 2. So we're going to multiply by our LCD to get rid of fractions. So our LCD is going to be 2. If it helps you to write 2 over 1, go for it. And we're going to distribute that LCD of 2 to every single term on each side of our equation. Our equation, remember, is y equals negative 1/2 x minus 9. So 2 times y is 2y equals 2 times negative 1/2 x. We're multiplying fractions, so we're multiplying straight across. 2 times negative 1 is negative 2. All over 1 times 2 is 2x. And then 2 times negative 9 is negative 18. Let's simplify it down. So 2y equals, what is negative 2 divided by positive 2? Negative 1. So negative x minus 18. So I got rid of the fractions. And then our last step is I want x and y to be on one side and equal some number. So I did move this x the other side. Add x. So we're left with our final answer of x plus 2y equals negative 18. This is in our standard form. There's no fractions. Our standard form member is ax plus by equals c. Boom, that's our final answer. We're done. X plus 2y equals negative 18. So we have one more example. Before we get to that last example, what questions, comments, or concerns do you have for me, please? All right, if not, let's knock out this last example. So it says a rock is dropped from the top of a 2,000-foot building. After 11 seconds, the rock is traveling 3,232 feet per second. And after 22 seconds, the rock is traveling 6,464 feet per second. Let y be the rate of descent, and let x be the number of seconds since the rock was dropped. What? All right, let's go back. So it says write a linear equation that relates time x to rate y. So what is, if we have average, the change over time, what's another word for that? Fraction. What else? A specific type of fraction. Yeah. Proportion. Specific type of proportion. Slope. Good, thanks. So we have 2 points that are relating x and y. We just want to put x and y together. How are these changing from one to the next? That's our slope. So we're trying to find the slope. So part A is to find the slope. So they give us 2 points. I'm just going to rewrite it down here. 11, 32, 32, and 22, 64, 64. So this is my first point. I'm going to label it x1, y1. My second point, I'm going to label x2, y2. So that way we can find the slope and we can plug it into our m equals y2 minus y1 all over x2 minus x1 formula. So whenever it says when it relates, a ratio is a rate, which is a proportion, which is a fraction. We're relating x and y, so putting x's and y's into a fraction, that's our slope. Our average rate of change is our slope. So exactly like we've been doing. So plugging this in, y2 we labeled as 64, 64, minus y1 we labeled as 32, 32. All over x2 is 22, minus x1, which is 11.
There's something awfully familiar about these.
Yep, 64 minus 60, bless you. 64, 64 minus 32, 32.
32, 32.
32, 32. All over 22 minus 11?
11.
11. If I plug that into my calculator, I don't believe it simplifies. Let's check. 32, 32 divided by 11. We get an ugly decimal. Let's just kind of check to make sure. I don't know why this is so close. Let's turn this into a fraction just to make sure it doesn't simplify. So second, hitting our PRB button, we'll go from a fraction to a decimal. Equals, it gives us that mixed number. I don't want a mixed number, so doing second, the ABC button underneath it turns it from a mixed number to an improper fraction. We still get 32, 32 over 11, meaning that's in simplest form. So it does not simplify. They have no factors in common. Final answer.
The next one's a trick question. It should be 0
Okay, keep that in mind.
because it would have hit the ground by now.
How does that even work? Yeah. If it was
For B?
2,000 feet,
Keep
It
going,
was
sorry.
a 2,000 foot tall building, and it traveled 11 seconds at 33,232 feet per second, wouldn't it have hit the ground like a long time ago?
It'll take like fractions of a second to hit the ground. Yeah. Which is like nothing. Yeah, that seems a little
That's you get hit in the head, you dead.
far-fetched. So basically it's like, yeah, less than a second to hit the ground. Yeah, it must be a pretty heavy rock,
Yeah.
right? I was thinking like a little pebble.
Oh.
No, this is gonna make a boulder. Look out below. Hopefully there's not like a cat or something underneath. Was that a morbid thought? All right, so part B. Use the equation to determine the rate of travel of the rock 1,212 seconds after it was dropped.
They give you X.
So they give us x, but I need to use this to I need to find an equation to plug into. So let's write an equation. Y equals mx plus b. So we have our slope that we can plug in, and we have a point that I can plug in. So let's plug in to find b. Plugging in our slope, which is 32, 32 over 11. And either point, let's plug in, the first one looks easier. So 11, 32, 32 to find b. So this is x and y, by the way. X is 11, y is 32, 32. So 32, 32 equals m, which is 32, 32 over 11, times x, which is 11, plus b. If it helps you to write it as 11 over 1, that way our 11s cancel each other out. We're left with 32, 32 equals 32, 32 plus b. So b equals 0. Subtracting 32, 32 from both sides, b equals 0. So our equation, y equals mx plus b, is y equals 32, 32 over 11x plus b is 0. So just y equals 32 over 11x. X is the number of seconds, so we're going to plug in 12 for x. To get our final answer. So y equals 32 divided by 11 times 12. It helps you to write it as 12 over 1. Go for it. So that way whenever we multiply fractions, we multiply straight across. So 32 times 12 equals that crazy number divided by 11. 39,17184 all over 11 times 1, which is 11. If I plug it in, it doesn't give me a pretty answer. It gives me a crazy decimal. So I don't want to do that. I just want to leave it. And this is the rate of travel. So what's our units? How fast? Yeah, feet per second. So our final answer is 39,171,184 all over 11 feet per second.
3 million.
3,917,184 divided by 11 feet per second. So that is all of Module 9, Homework 2 notes.